Welcome, everybody. Thank you so much for joining us for our second event in this series, Serverless Deep Dives. This series is dedicated to just talking about serverless, just exploring the ecosystem, and getting together with just professionals in the field who have stuff to say about serverless. And I think the serverless ecosystem is one that deserves a lot of attention right now. Many see it as the future of deployment, and there's just so much going on in it right now that we wanted to create a space to consolidate the thoughts of the people actually working in the field and just sort of share this knowledge. So I'm really excited about today. If you missed our first event, we had Alex Debris and Jeremy Daly on. They were amazing speakers and they brought a lot of great insights. And today we have two other really, really good speakers. We have Yan Cui and Taylor Barnett from PlanetScale. And so we're going to be chatting with them. And then just like last time, we'll have a quick panel where we just sort of take any questions that you might have and then talk about a couple of topics that we've prepared as well. So at any time during the stream, please feel free to go in the chat and leave questions. We'll be monitoring that and taking note of any questions you might have so that we can discuss them near the end. But to start this off, I'm going to bring up Yan on the stage, and we're just going to have a quick chat here. So let's go ahead and switch over there. Hey, Yan, how's it going?
Hey, man. Thanks for having me.
Yeah, of course. Thanks so much for coming on. We were really excited to get you. I've listened to your podcasts and I've sort of followed you on socials for a long time. And I'm always just really impressed with like the insight you have and the knowledge that you bring. And you're like one of my go-to resources for serverless related stuff. So it's great to be able to have you on.
Yeah, thanks for inviting me. I'll have to listen to the last episode you guys did with Alex and Jeremy as well.
Yeah.
Stuff.
yeah, for sure. So I think to start off, I mean, we have a lot of great things to talk about, but to start off, why don't you tell us just a bit about yourself and sort of what you do so that we can sort of get that context into where your experience is coming from.
Yeah, sure. So my name is Yan. I'm an 80% serverless hero. I guess nowadays I work as an independent consultant. I advise companies on how to make the best use of serverless technologies, and I run workshops, and I do, some hands-on development work as well for some clients. I also do some side hustling with Lumigo as a developer advocate for them as well, helping them with a lot of the content and stuff they do because I'm a big fan of their product. I've been using 80% since about 2010 and went through the whole journey of running EC2 instances to then trying out containers. And then I think 2016 was when I really went big on the Lambda, just after they added the support for API gateway. So you can actually build real meaty applications using entirely serverless components. Nowadays I mostly just work with my own clients. That's kind of what I've been doing.
That's awesome. Yeah, great. It's really cool that you get that context of working through all the different kinds of deployments through Amazon, working with, you said EC2 containers and stuff like that, just being able to go through. How do you feel now that you're working more in serverless? How do you feel that compares to how you would deploy applications before? Do you think there's trade-offs to both, or do you think one of them stands out more than the other?
There's definitely a trade-off, and I have to say, there's no one solution that's going to work for all. I think that the Prime Video blog post recently is a good example of that your context will change over time. In their particular example, they built something quickly, they wanted something done quickly, and so they went with Lambda, but over time they realized the throughput was really high, and what they had as version 1 wasn't cost efficient, and so they moved things that we architected, and they moved things to ECS instead. Because when you're running a really high throughput, things like API gateway and Lambda can get expensive, and so there's no one solution that's going to work for everybody. But I have to say, from my personal experience, I spend I used to spend maybe like 70% of my time just doing stuff that enables me to do the stuff I need to actually do. A customer wants to have a login feature, or they want to have this new feature, and before I can do that, I have to spend a bunch of other time to set up machine images, to patch the OS, to set up auto scaling. There's this whole other networking stuff I got to worry about before I can write that 2 lines of code to give them what they actually need. So for a lot of applications that I've built in the past, I don't need all that control around on my infrastructure, and so being able to focus more on just shipping features, it just makes a lot more sense. So I can probably spend 80% of my time thinking about how I'm going to develop this feature for my clients, for my customers, as opposed to thinking about, okay, when was the last time I patched my machine image? Do I need to install some new security updates and schedule that in and things like that? And you read about the recent Datadog outage where you can have one machine image update that breaks the whole thing. There's also things like that I don't have to worry about anymore, which I think is great. For maybe 95% of the workloads I've seen out there, there's always going to be exceptions. That just have to be, you just have to expect that. But I think for most workloads I've had, serverless is the most reasonable or the more sensible approach to building them.
Yeah, and I think that really highlights sort of the value that serverless brings, and just sort of thinking through the evolution of deployment models over the years. I think that hits it like right on the head. Is that it seems like we are pushing more and more of these like menial tasks that you work on to get to coding. We're like handing more and more of those off to the cloud provider so that you can focus on what you want to be doing instead of configuring auto scaling and doing all of this kind of stuff.
Yeah, and it's not just the deployment model; it's the operational model as well. It's the fact that there's a lot of things that you have to worry about in terms of updating security-wise. Not having to worry about the security of the operating system itself or the underlying infrastructure. That's 2 whole layers of security that I used to have to worry about. I mean, back before when I started working with AWS, there was no VPC, so everything you create just open, public.
Yeah.
And so I remember every time I bring up a new instance, straight away I can see in the logs that someone tried to log in via the port 22.
Oh gosh.
So pretty much immediately, the moment that the instance is up, but there's someone tried to connect to it, and it's not me. So not having to worry about any of that is also a big reason why a lot of the enterprise clients I've spoken with, they are going to serverless, especially from the finance sort of industry, is thinking about, security. So it's great. Using serverless means that we are by default compliant with a lot of the regulatory requirements that we have.
That's awesome. So it sort of lowers the bar of entry then for getting going, building scalable applications.
Yep. Yeah. I mean, serverless is very scalable up to a certain point, and I'm happy to talk about some of the cases I've had in the past where we run into scaling limitations around Lambda, and where Lambda doesn't quite make sense.
Yeah, I'd be very interested to hear some of that. Yeah,
sure. So one of my last full-time jobs working with a company called The Zone, which is a sports streaming platform. I think when I was still there, we had a peak about 2 million concurrent viewers. So imagine, a big football match or soccer match, as you call it, kicks off. They will have 2 million people all logging in within about 30 seconds. So in terms of the traffic spike, it's just super, super, super steady, and then boom, it's got this crazy spike. And Lambda, you can have as much concurrent execution as you want, but there's a limit on how quickly you can reach that peak concurrency, and that's where you have a hard limit you have to deal with, which in most regions is 3,000. Which, if you think about it, it means you can go from 0 to 3,000 instantly, and a lot of companies actually use that. Like a supercomputer, because you can have up to 6 CPU cores per execution. So it means you can go from 0 to 18,000 CPU cores to do some genome sequencing and things like that, which the Australian government's Cicero department does that to analyze the COVID genome sequences. So they use it like a supercomputer, which is great. But when you're doing most of transactional workloads, like user logging in and want to watch your football match, that spike means that you can hit those scaling limits. That's one area where when you're hitting those scaling limits, Lambda becomes not a good fit for APIs that have to sort of serve customers along that critical path of logging in, checking an API, what match is on, and then clicking on a match and start watching it. Except for a few APIs we had, which the API responses are cacheable, so that it didn't matter. We can just run it on API Gateway and Lambda, because most of the time you're just hitting a cache anyway, so you're not really hitting our backend. So that's one example of where Lambda is not we couldn't use Lambda because of how spiky the workload is. But for most applications that don't have sort of unpredictable spikes that are not so crazy in terms of the magnitude, Lambda is great, because running containers, you have some flexibility, but oftentimes you still have to wait for the underlying EC2 cluster to scale, which takes time. And you have this problem of CPU saturation, and then all of a sudden all the concurrent requests are performing worse than before. Whereas with Lambda, every user request is handled separately. So in terms of that concurrency and the parallelism, it's a lot easier in terms of the what you have to do as a programmer.
Yeah, definitely. Now, you'd mentioned a limit, and I think you said 3,000 of concurrent. Is it concurrent functions when you're working with AWS Lambda?
Concurrent execution. So think of it as you can have one function that is executed 3,000 instances at the same time. And that 3,000 is how quickly it can go from 0 and having to scale that out to how many concurrent executions of your functions within the same region.
Gotcha. Okay. So it's a pretty big limit, but once you hit that limit, it is sort of a hard stop, right? Like
it's a hard stop. And the funny thing is AWS, once you're a big enough spender, AWS is happy to negotiate hard limits on a case-by-case basis. But when you're thinking about system design, you also don't want to build your system using a service that you're just going to be a matter of time before you hit that limit.
Yeah.
So even though they're happy to sort of push the limit slightly for us, as based on our use case, you still don't know. I think it's still prudent for us to try to look at the services we're using and trying to figure out where it's best fit.
Yeah, for sure. That sort of brings up a question that I had planned on asking you, and that is around the idea of vendor lock-in. You hear that a lot in terms of serverless. A lot of what people are using are software as a product, or like AWS Lambda. And once you hit these limits, it seems like it would be pretty difficult to move off of whatever software you've chosen to use. Is that sort of the experience you've had, where there's a real problem of vendor lock-in in the ecosystem?
Not at all.
Not at all.
I mean, if the Prime Video blog post is anything to go by, they actually talk about this, how they were able to write their code in such a way that it was easy for them to move from Lambda to containers. And we've done the same thing in the past as well, where we were building services that we weren't sure if it's going to be running in containers or in Lambda functions. So you can use what is called hexagon architecture. There's one way where you can modularize your code in such a way that the same business logic can be invoked or accessed by some kind of like a wrapper layer that connects, say, the Lambda interface to your business logic, or from, say, Express.js app or Django app, whatever, to your business logic, so that you're not tied to specific services that you're running on. But I think this whole vendor lock-in argument is just an easy thing people throw around to justify why they don't want to try this thing that they never bother trying in the first place. And I think if you actually go into it, that usually comes in two flavors of this vendor lock-in argument. It's either, you're going to be lock yourself into AWS, so they can just do some price gouging later once they've got you in their pocket, which. I mean, if you judge someone based on what they've actually done in the past, which is what we do, right? The evidence actually says the opposite. AWS hasn't done any price gouging in the past. If anything, they've consistently reduced price for their services, and the same goes to all the other cloud providers as well. Because over time, things that they become more efficient, they can offer their services for cheaper, and also the fact that you got Google, you got Microsoft, and Ali Cloud, and those other competitors means that you have to keep your prices competitive for customers to keep using you. The other side of it, this idea of that, you can't move your workload away from whatever services you're using, which as we just talked about, is not the case. And also, the worst thing that's going to happen to you is you have to rewrite the application. But that's more about the cost of moving, the cost of changing your mind later. And that cost of moving or that coupling exists not just with Lambda or containers, it exists at every single layer, right? The fact that you chose to write your application in JavaScript or Python, that's a lock-in to your language. The fact that you chose to write your application using Express.js or Fastly or whatever, that's a lock into a particular framework that if you want to change it later, you have to, more or less rewrite your application, or at least a big part of it. So those kind of coupling and the moving cost is associated with pretty much any technology choice that we make. So there's nothing special about using Lambda or containers. In fact, using containers itself is a lock into a specific set of technologies. Docker may not be around forever. There was a competing format, which I think is kind of quietly run away now, I think called the Rocket. There's also Kubernetes, and also there was other similar container orchestration services that kind of lost out. But people that use those technologies may have to suffer the same moving cost of having to move to Kubernetes because whatever they were using has gone out of business. So that moving cost exists with pretty much just anything that we actually use. And a lot of people that talk about vendor lock-in, they're not talking about the stuff that they are doing in order to prevent vendor lock-in, which is creating a lot of legacy code, custom abstraction layers that now they've locked themselves into, so that in the future, if they realize, oh, this doesn't do what we want to do, or it's no longer state of the art, or maybe just crap. Now you're logging into that, and now you have to put a lot of effort into moving your entire system away from the legacy code that you created at some point because you wanted to avoid using managed services. So yeah, this whole vendor lock-in thing, it's something that you should really think about, but don't think about it in terms of lock-in, but think about it in terms of how much coupling you're creating and what is the cost of moving, and also what's the likelihood you actually would need to move at some point. And I think Lambda is probably the least thing you got to worry about. If I was someone who's an enterprise architect, I'm thinking more about the data, because unlike compute and stateless computation, which is easy to rewrite and change or whatnot, data is where the problem is. Data has gravity, and different database technologies have different constraints. So we're going to hear about PlanetScale pretty soon. They don't work exactly the same way as DynamoDB or any other database that you're going to move away from or to. And so you have to do a lot of rethink in terms of your architectures, your code, and lots of other things. And moving data, especially where you need to keep the system up and running 24/7, is not easy. So that's probably what I worry about more than say my stateless compute, which I can just change 2 lines of code to run in, a different platform.
Yeah, no, I really like the points you made here, that any technological decision that you make in your application, to some degree is a form of lock-in, because you're making a decision on a specific product. I think the important takeaway from what you just said here is that it's really important to plan the way you architect and build your applications, depending on your needs. If you'll need to move off eventually, having that wrapper layer that sort of abstracts the platform you deployed to from your actual code, it seems like that's really the important takeaway here, is that there's no hard lock-in. It's more of just what your needs are and how you plan your application.
Yeah, and I also think having small and independent services really help. So you don't have to move the whole thing in one go. You can move and rewrite one service at a time, which allows you to both learn about the new technology that you're moving to, but also plot out a path on how to do the migration more easily going forward. And also, I also think that to guard against any kind of form of lock-in or risk with one using one provider or putting all of your eggs in one basket, is having that agility to be able to move and rewrite services quickly. And there's no better way to get that agility than to use managed services that minimize the amount of custom code that you have to write and maintain, and later on potentially migrate.
Yeah, for sure. And that's a great point too, because with serverless, it is a different mindset where the whole goal is that you're deploying small, sort of isolated services that do different things, rather than large applications that handle a lot. So it seems like getting to that point where you have small services that you can migrate easily isn't as difficult as it would be in maybe other deployment platforms, because that's sort of what it's intended to do anyways.
Yeah, and you can move incredibly fast. I mean, I've been able to build things on my own for my clients in a fraction of a time that you would take a whole team to do the same thing just a few years ago using different technologies. So, I mean, the ability for you to move very, very quickly, even with a small number of developers, I think that is a huge win in terms of getting time to market down significantly, but also in terms of when you need to do that migration to different technologies later on. If you ever need to move, say, from AWS to Google or to Azure or whatever.
Yeah, definitely. So when you're developing applications, what are like some of your go-to tools that you use? Like what are you developing with, and are there any tools that help make developing locally easier for you?
Sure, I use the serverless framework. Also tried SAM and CDK before, but I still think the serverless framework is works best. And also for observability, I use Lumigo, which is a company that I'm a big fan of, and also I'm helping them out with a lot of the content stuff they've got. In terms of local development, I actually don't do local development in the sense that I don't try to simulate AWS locally. But when I'm writing my Lambda functions, I do like to test them by running the code locally, but having the code talk to the real AWS services, the real DynamDB tables. So that's where things like the practice of using temporary or ephemeral environments comes in. So when I start a new feature, I will say, maybe add a new database table. I'll deploy to my temporary environment. So I'm not going to step on anybody else's, toes. And then as I'm writing my new Lambda function that use a new table, I can run tests that execute the function code, because it's just a function code, right? That talks to my new database table in my new temporary environment, make sure everything's working. And then I deploy my function, create new API endpoints, and then I run end-to-end tests to make sure that the whole thing is actually flowing and connecting correctly, especially if I'm using direct integration between, say, API gateway or AppSync to DynamDB. So no Lambda functions to test and run locally. Then I can also run end-to-end tests to make sure the whole thing is working there as well. And then when I'm done, I can just delete my temporary environment, merge my code. It runs, goes through PR and runs the integration tests in the integration environments, and then get promoted to all the way to production eventually. And then use the tools like CloudWatch and Lumigo to keep an eye on things as they're in production.
Now, when you say you set up end-to-end testing for these things, what tools do you use for that? Because I think that's a topic that a lot of people get confused on with serverless, is how you set up like proper testing environments for it.
Sure. I just use Jest for both. Well, I should probably move to the what's the new one called?
Vitest?
Yeah, but that's it. Vitest.
Yeah.
I've been meaning to check it out because I think Jest is not been updated for a while. So I think there are some rumors around it's being abandoned. But yeah, I just use Jest to write my unit test, my locally executed integration test by running my Lambda functions locally and talking to real AWS services, and then to also run my end-to-end tests as well. Because once I've deployed my application, I've created my API endpoints or whatever. And for event-driven architectures, I've got my event buses and queues and topics, which I can trigger my business logic behind them by just sending a message to those event buses or topics or whatever. And then I can make sure that whatever side effects I'm expecting them to do actually happens. So there's a certain way I write my test so that it works for both an API functions as well as for more so event processing functions. And I've actually got a video course that covers my whole approach towards testing as well.
Oh, awesome. You'll have to send the link to that video course to
sure.
me, and I can get it in the show notes so that people can find that.
Okay.
One thing that I sort of think of as you describe this is the services that are set up that you use during these tests. I assume these are all set up through the serverless framework. So you're not actually going in and configuring things in AWS just so you can test. It's all set up locally through that file, right?
Yeah, so all of my resources are either prefix or suffix with the name of the environment, so that you can create as many of those logical environments for your application within the same AWS account, so that they don't clash with each other. And the server framework kind of does a lot of the work in terms of making sure that the function names has got the environment name in there, or your cloud formation stack has got the environment name and things like that. So there's a few resources that when you're creating them with CloudFormation, you have to name them yourself. That's where you have to be a bit careful in terms of how you name your event buses, for example, and making sure that you've got the environment name in the bus name, so that when you create another one for a different feature, you're not going to clash on the name of your event bus.
Gotcha. Okay. And does developing in this way ever incur costs from your testing environments? Is that just something that comes along with the process?
So if you're only using serverless components, as in components that are not charging you based on uptime, then no. I mean, having 10,000 Lambda functions has the same cost as having one or no Lambda functions, because you only pay for them when it runs. Having said that, when you're using server full components, like you've got RDS database and the VPCs and things like that, that's where you may have to think about sharing the same database cluster across multiple environments. So you, instead of having the database being created as part of your application stack for each environment, you create it as part of your part of the account, so that one account, like dev account, will have one database cluster, and then every environment will have its own database tables within that cluster. So you will have orders underscore Yan, or orders underscore dev feature A, or something like that. Same goes to things like OpenSearch, so that you can have the same OpenSearch cluster, but then you create different indexes with for each sort of entity and environment. And then you have some scripts that cleans things up when you create this environment. Sorry, when you delete this temporary environments.
Gotcha. Okay. Yeah, that's actually really cool. That's seems like an interesting way to set it up to sort of avoid some of those extra overhead that you would have otherwise. Very cool.
Yeah, it makes testing a lot easier, and also means that you can have as many people working on the same code base without worrying about hitting each other's, triggering each other's functions unintentionally and things like that.
Yeah, nice. Very cool. I think we're getting pretty close on time, but I also wanted to ask before we wrap up here, are there any tips that you would give to people who are getting into serverless that would help them sort of start their journey in the right direction to get a lot of these good ideas that you have going?
I guess check out my content on the burningmonk.com, and also subscribe to Jeremy Daly's newsletter, just so that you keep keep up with a lot of the stuff, practices and ideas that are emerging from the community, because a lot of these things are still being sort of worked out by different people. And I think there's a lot of really great content creators out there now that focus on serverless. And I've got workshops as well that you can check out, called the Production Ready Serverless, which I've been running for a few years. And I've been every time I run it, I update it as well, make sure that it's current. So there's a lot of contents out there, I guess, in 2023 that's going to help you get started. But I tend to find that having one set of courses or one set of workshop helps, because different people has got different ideas, and having some kind of end-to-end training is going to help. But yeah, otherwise, just check out some of the contents I've written, and also Jeremy Daly and other people as well.
Yeah, for sure. And we will get that posted in the comments if we haven't already. A link to your course so that people can go through it. I totally agree. When I was jumping into the serverless world, you Google things, you start to figure things out, but everyone has their own way to do stuff. So it's nice to follow through with somebody and do it the way they do it, just so you can learn the concepts, and then from there you can tweak it to fit your own needs. But so I think that's great to just follow through. Like you, for example, your course, and just use that as a starting point.
Yeah.
Cool. Well, thanks so much, Yan, for coming on and talking with me. This was really great, and I think we got some pretty good insights out of this. We will see you back at the panel, but for now, I think I'll let you off the hook, and we'll switch over to Taylor.
Okay. See you guys in a bit.
Thank you. Hey Taylor,
Hey,
how are you doing today?
good. How are you?
Oh, I'm doing very good. Learning a lot. My brain's
Yeah,
already swirling with stuff I want to go play with after talking to Yan, and I'm sure it'll
yeah,
be swirling even more after your talk. So
yeah. It was a really good conversation.
yeah, very cool. So I understand you have a little bit of a presentation for us, and then we'll kind of chat about it afterwards. Is that
Yeah,
right?
yeah. I've got a short thing, and we'll chat some more after.
All right, great. Well, I'll pull myself off screen for now, and I'll let you do your thing.
Awesome. So I have just a very short talk just to kind of kick off this conversation that I want to go through. Okay. So, what is a serverless database? This is a question I started asking myself a couple of years ago. I'm going to get the obligatory, it doesn't mean that there aren't servers out of the way. But first, who am I to talk about this? Pretty much everything I have done for the last 9 years has been about either data or APIs or some combination of those. APIs for me was that real start of a shift of complexity to basically someone else's servers, which is much like serverless. And I also think a lot about data API and APIs and how those like intersect and what's the developer experience of working of these together, because we build pretty much everything on top of these two things. And so for databases, it's important to know that you can't just like easily lift and shift a database built before the serverless era into a serverless architecture. Today we can literally create and destroy thousands of compute instances in seconds. That was not a thing in the past. And because of this, there's all sorts of connection and networking and scaling and operational challenges that exist. And while I wish I could give you one very straightforward answer for what is a serverless database, the reality is that there is no one definition. Not every database provider agrees on how a serverless database should work and look, as well as talking to many, many developers. All have different perspectives on how this should look. And some of this comes from different product requirements they have or just operational requirements. We all expect a little bit different things out of a serverless database. So I kind of want to shift the conversation to what a database built for serverless might look like. Serverless today is more of, kind of like a thought process than an actual technical definition. At least it's become that way through marketing and just like an explosion of popularity. Just saying serverless is not going to really give like any developer the information that they need. That's the reality of it. It's more of a operational style, and there needs to be a lot more context to it most of the time. But there are a few things databases built for serverless, I think, share in common. So I'm going to go kind of quickly through some of those. First, they're all fully managed services. You can have a managed database that might not be serverless, but pretty much every database built for serverless is fully managed. There can be also levels of how managed that is, but someone is technically on call for your database. You are not doing the operational heavy lifting. You're not worrying about updates, networking, hardware. None of those things are on your plate most of the time when you're using this kind of database. Second, they're all focused on supporting scale. Scalability is hard, whether that be in like a vertical sense or even in a horizontal sense. In a non-serverless world, that was often a very manual thing. You had to do lots of work to do any sort of scale. Serverless expects, though, being able to scale up and down and handle spiky workloads. But what are you actually trying to do with your database? That's like the question, instead of being like, what is a serverless database? Like, what are you expecting out of it? What we're expecting out of a database hasn't really changed in the last few decades. We want a predictable data model that we can somehow develop on top of. We want to be performant and consistent and available with very little effort. And we want to be able to scale. And this has been an issue for decades now. Everyone wants to be able to scale 100x just in case. But serverless architectures often help some of this future proofing. They avoid that period of time later where all the engineering work just evolves around figuring out like how to scale the database when you could be building product instead, because that's what's really important to users. That's what makes you money. That's what gives us jobs. That's what we really want to do, is build product. And serverless as like a concept is really about outsourcing these non-differentiated aspects of our infrastructure. All databases built for serverless are full of abstractions. We aren't looking at the exact CPU usage on one server. You probably don't know what instance type you're on, and other things about your underlying hardware or networking, for example. These all live below a line of abstraction. Instead, we think about the things above the line of abstraction with databases built for serverless. Behind the scenes, providers are often helping do sizing of resources for you so you can focus on juggling less things. And a lot of these abstractions come from them doing those tricky, annoying, tedious things behind the scenes. That doesn't mean, though, you will never see some of these things, although you're probably never going to look at the CPU usage on the exact server. You will not know the exact server that your database is running on, but you'll think about these things a lot less. And these databases help you avoid manual database maintenance tasks that no one else likes to do. They're better for testing and experimenting and evaluating. You get faster feedback loops when you're building product because there's less upfront manual work to spin up a database, for example. And so while some of the old challenges have been solved, that doesn't mean like everything is solved. There's just new challenges. I like these new challenges, though, because I think they're a lot more interesting because they're much more user-centric. They're things that your users actually care about. Like, your user does not care what database you are on. For example, in a serverless architecture, often a function opens up one or more database connections. These are often, there are no long-lived connections in this architecture. The database has to be able to support a large number of these short-lived connections and have very little overhead when opening up these connections. If you get a lot of traffic, you're at risk of maxing out connections. That has been historically a problem with many of the databases just trying to lift and shift into a serverless architecture. You either need to implement some kind of connection pooling or have a database that can support a large number of connections. In the first serverless deep dive, if you caught the last one, Alex actually went over this like connection problem. I didn't want to like reiterate everything he said, so like go watch that because it's definitely a real problem, especially in serverless architectures. Next, ops does not go away with serverless. Like, DevOps does not disappear as a philosophy, as a team, as a person, whatever. It causes our complexity and our concerns to shift. Back when we talked about abstractions, this plays a lot into it. Another example would be like auto-scaling. It's like a great in theory kind of thing, but what happens when it causes runway costs? Like, it needs some kind of limitations. It needs better systems to operate in, and we have to rely then on database providers to like help us manage these abstractions and give us enough insight, but also not overloading us and turning into something that doesn't feel as managed. Distributed infrastructure adds a constant network pressure to literally everything that we do. It's highly unlikely that your database is going to live on the same rack as your application code. Those days are mostly gone. So suddenly you've added these millisecond hops all over your app, somewhat secretly. Some you may realize. But one of the things is, I think, when we talk about database latency, I think we often forget about literal physical distances. We are bound by the speed of light. That is not going to change. There's only so much we can do there. So a lot of times it's about figuring out how to operate within these constraints. A solid staging environment can help somewhat, but what you really need is to be able to see these things in production and figure out what is an acceptable amount of latency, what is not an acceptable amount of latency, and being reasonable within that. But, we try to run our databases as close as the app as possible, but, there's other constraints within that, like cost, for example. If you're going from one data center to 20, like costs are going to rise. So what is the reasonable amount of latency and consistency and all these different concerns that you have to like find the middle ground on, rather than being like, we must be in 250 data centers, or maybe a few, or maybe just one for certain things. Like, you just have to find all these balances. Configuration hasn't gone away. It just looks different. Just because something is serverless doesn't mean it should be some magical black box. This is often how we get ourselves into trouble later when something goes wrong and we have no idea how it works. We've all been there. One example is database client settings can dramatically affect performance. Spend time learning about them, learn how to write better queries, and how that affects like your actual user's performance. Your slow queries of the past will still be slow on a serverless database environment. A bad query might return something eventually, but like, what is the user experience of that? What is the cost of that query? And it's always going to be something that's important to your users. So take the time you save elsewhere, some of the operational challenges and things that you save on, and shift that to refocus on query performance. I like to say 98% of business use cases aren't unique. Everyone sometimes thinks that their thing is like some special snowflake application. Reality is it's usually not. Sometimes people are like, but I want more control over some of these things. The reality is like, what are the trade-offs of that control? But if you need specific control over how the database operates and have the time and the expertise and the team to do it, maybe serverless isn't for you. There's very specific things like not having a cloud-friendly architecture, needing some kind of on-device storage, or like really strong on-premise requirements that you really can't find some hybrid that works. Another concern is often vendor lock-in. I know they talked about it right before this, about vendor lock-in, kind of more on like serverless compute side, but in databases, that's real. Use trusted standards, MySQL, Postgres, like use things that you could hypothetically lift and shift, and ones that can maybe lift and shift from different clouds too. I know that was really quick on like a very big nuanced topic. Thanks for listening to that. And I think Sabin's going to come back and we're going to talk a little bit more.
Yeah. Thank you so much for that. That was a lot of great insights in there, and definitely a lot of stuff that got my brain going for some conversation here. So the first thing I want to talk about is you mentioned in there sort of like how to think about a serverless database and what a serverless database is. But we see so many different serverless databases popping up, like PlanetScale, like Neon, a bunch of different ones out there. How do these different databases compare to each other? What are the differentiations between the two?
Yeah, I mean, part of it is, there's a lot of similarities. I think one of the big things is like different people's interpretations of what a serverless database is. Like I said, like different developers expect different things out of their database. One big thing that has been like a debate probably across developers, the industry of databases and serverless, is like this concept of scale to zero. Where did scale to zero come from? That came from compute, basically. Like that we didn't want to pay for a server to be running at all times so that anytime our application needed to be used, or API or whatever function, like we didn't want to spend money on that. That makes a lot of sense in like a compute type environment. Does it make as much sense in a storage type environment? It's great for hobby projects. I totally understand not wanting to spend, or maybe companies just getting started who don't have funding or aren't making any money. But, do we really want our databases to have to navigate cold starts? Like that does not feel like a great developer experience to me. Like I think back to Heroku and how we used to like ping the server so that it never went to sleep.
Right. Good times.
Yeah. And like, we definitely don't want to be doing that for a database. It's just not a great developer experience. It's not great for performance. And so I think, some people, they've come to terms that like performance and developer experience is a little bit better, like more important than being concerned about scale to zero. Some have kind of put another layer on top of the database that is above whatever relational database it's built on top of, like, and actually put like an API layer. That kind of gets into that awkward vendor lock-in. There's questions of like, what if we just made it better and easier and educated people how to use a relational database directly instead of needing an API layer to just like do anything on the database? There's different viewpoints on pricing and consumption-based pricing. There's different viewpoints on how auto scaling should work. If you have auto scaling, like just all these, there's all these like interpretations. And I love that those conversations are happening. I think sometimes we try to adhere to the fundamentals of serverless that came from the compute side too strongly, and don't think enough about what do someone actually need out of a database.
Yeah.
And so that's why I kind of wanting to shift this conversation about what is a database that's good for serverless, rather than it has to be a serverless thing. And if it does this one thing, it's not serverless, like that kind of, opinion.
Yeah. That's a common thing I've noticed with developers, is that we get something and we learn about it, we understand it, and then that sticks in our brain and we want everything to work that way, whether it's good or not. And it really, you need to take a step back and think, does this make sense for what I'm doing right now? Does it make sense in this context?
And for users.
Yeah,
again,
exactly.
What does users want in the end? They just want the app to be fast, and they not ever realize what database you're using. Like they never want to see in your incident page there was a database incident. Like that scares you, especially when you worry about things around like resiliency and data loss and stuff. Like they don't want, so to me, yeah, I think it needs to go back to what are we actually building product wise, and what do users expect, and then work back to then what are the requirements of the database.
Yeah, definitely. And you mentioned the topic of scaling down to zero and whether that even makes sense for a serverless database. But there's also the opposite side of that. When, like, I know when I first started getting into serverless and I started hearing about serverless databases, I imagined, just like serverless, that there would be multiple instances of it that can spin up and have your data magically. That's not always the case. And most of the time, that's often not the case. Can you sort of talk about the scaling aspect of serverless databases and what that actually means typically in the system right now?
So yeah, historically, a lot of the scale that we're doing is vertical. So we're just constantly adding to bigger, larger, in a traditional database sense, bigger, larger instance sizes that have better, bigger hardware that underlines it. There are limitations with vertical scale. You can only go so high. There can be different types of performance implications of that. At Plan Scale, we're a big fan of more horizontal scalability. For us, this comes from a project called Vitess. Vitess was created back at YouTube when they were having scaling issues with MySQL. And so it was a way to horizontally shard your database so that, it could scale, and that the application necessarily didn't need to know like the sharding scheme. Vitess was smart enough to just go get the data from where it needed to get it from when you made a query. A lot of what is still being done is just vertical scale. But the reality is, like, your really big, large enterprises, like they just can't do that. And also there's cost. So with being able to horizontally scale, you can have cheaper hardware. And so it literally becomes cheaper rather than just like keep adding more and more things vertically. So there's trade-offs, and different databases go about that scaling piece in different ways. I'm most familiar and fan of horizontal scaling because of a lot of those different reasons. But yeah, it's the scale piece, and scale means something to everyone differently too. That's like startup. When you talk to them about scale, it's like them going from having, 100 users to 1,000 users. That's like, a type of scale interpretation. Then when you're talking to some large Fortune, 500 company, like their scale's a little bit different. And it's just like an interpretation thing. And, I think I talked a lot about the scalability on the serverless databases. The idea is that a database that's built for like the serverless environment could handle either versions of that scale. That you shouldn't have a database that in 2 years of business, then you have to go change your database because it no longer can go from that startup scale to Fortune 500 scale. Like you should be able to use the same thing and maybe use different features part of it, but like it grow with you.
Yeah, for sure. Yeah, and I think that that's an interesting point right there, because that also sort of plays into the idea of vendor lock-in within databases. You mentioned it, and Yan and I talked about it. It's not so much a problem on the compute side, but on the database side, your data, I mean, that's the heart and blood of your application, and you can't really move that around. You can't really change it. You can, but it's very tough. And this becomes more of a problem, I guess, in serverless, because there's limited options to what offers this. I think as we see more and more databases come out, like PlanetScale, for example, CockroachDB, there's a bunch of different databases that do things in different ways. So really taking that time before setting up your application to think about, okay, what's the future of my application using any specific database? Am I going to have to switch later on? If so, I probably shouldn't go this route. All of that becomes like mental overhead that you need to think about beforehand. So I think that's sort of the trade-off in a serverless system is, you give away some of this like management of your infrastructure to the cloud provider, but then you have to do sort of that thought beforehand to make sure you're making the right decisions up front.
Yeah. And that was often, I first started working with data when Mongo was becoming really popular, and NoSQL, like the first like data product that I worked on was built on top of Apache Cassandra and some, more Apache type software, but it was like a nice event data API layer on top of that. And that was schemaless. And I remember the challenges of like people realizing down the line they needed to change the schema and how painful that was when they were hitting different, inflection points of their product or company. So I'm really glad that like relational has become exciting again, because it is something that can grow with you. Like you're not gonna start with relational and then suddenly realize that was a mistake. I think a lot of that little upfront work is pays off in the long run.
For sure. I worked for a company previously where we were running on SQL Server. We'd been running on that for years. But like right when Mongo began to get super popular, we spent engineering efforts and we moved everything to Mongo. And then within like a year or two, not that Mongo's bad, it's great in certain contexts.
Yeah, it's great for its purposes.
Yeah.
Putting everything on it.
So we jumped on that bandwagon and quickly realized like relational databases still definitely have a role to play. And like you said, it's great to see more attention being spent on these right now, especially moving to these new deployment paradigms. They're sort of like the default that you go to now, and I'm really happy to see that.
Yeah, totally.
So you work at PlanetScale, and I'm a big fan of PlanetScale. I use it for most of my personal projects. So I'm excited to talk to you a little bit about that. I'm curious about how PlanetScale, how they had to shape their product to be able to work in serverless and even in edge environments. I mean, it's a difficult problem. You mentioned Vitesse, but I'm sure there's a lot of other stuff that went into it as well.
Yeah. So the ability to handle a high number of connections, that comes from Vitesse. That was not necessarily something that we had to build on top of. We gain the many, many work hours that have gone into Vitesse over the last many years now, over 10 years. I think started like 2006 or 2007. And so, a lot of what we do is just utilizing features of Vitesse. There's so many more things that we can build awesome, unbelievable things that we can build basically on top of a test. So it already helped in like serverless environments. Edge, a little bit more of a layer on top of then the serverless environment. We have to with Edge, it needs to be able to work many times in like these constrained environments that only use HTTP and are like fetch compatible. So a few months back, some people might have seen database.js. That is just a library, really a driver is what it is, to help translate all the amazing engineering work that actually went into that infrastructure work to be able to work in these HTTP. Because before we were only using the MySQL binary protocol over raw TCP sockets, which is what any MySQL database does. And that was a lot of work of adding a gRPC API on top of that. The driver is then translating basically what comes from that API into an actual like usable thing, because it's not exactly like, if you look at the way it spits out data, it's not the same representation that if we just like ran a query in MySQL. There was a lot of work that went into like just making a more modern TLS stack for faster connections, using things with HTTP2, just different protocol compression, like just like a ton of engineering work that went into that. And then the nice thing that everyone then gets to see is database.js. There was also one other piece is we're now doing like global routing for connections. So that's not to be confused with we're routing to a database on the edge. We do have read-only regions that you can create, but this is just more for routing of the connection itself back to your database. So it did speed up some of that connection, which is, when I talked in my talk about these short-lived connections need low connection overhead. Right. This helps with that. We were seeing, 100 millisecond type faster connections in like the US from West Coast to East Coast as an example. But yeah, so like there was just a ton of work that went into trying to make MySQL be able to be used in these edge environments that are much more constrained than your typical serverless environment that can use, the MySQL protocol with like a library like MySQL 2, for example, or Prisma.
Yeah, that sounds a lot like Prisma's story right now, where we've got a product, but with the serverless and the edge becoming more and more relevant, tweaking little things to make that experience a little bit faster. There's so many little things you can do, so many little differences when you're working on small isolated functions that are running all over the place. So many things you can do to just speed up even just a couple milliseconds, maybe a couple dozen milliseconds, and it makes all the difference. Totally.
And also like part of that is just things with HTTP 2 and 3 now, like we're kind of fighting against like it not being compatible with everything. Like the most common place it is compatible is in the browser. So we actually use database.js for our console where you can like run MySQL queries and stuff in it. You can use it in database.js, but like we would need to write drivers for everything else to be able to use it. We need other parts of the broader infrastructure of the internet to support some of these things to really kind of push it along. So we're playing a balance of what does the internet like support and what can we do to speed up some of these things?
Yeah, absolutely. I see a question in our chat, like our private chat from Yan, and he's asking, does PlanetScale have a data API, a way to access your data through an API?
So talking about those things, like, so database.js is the closest thing we have to a database API. So underlying is a gRPC API. It is not documented today. One day we may document it. But the reality is we really want to work closely with people when they are building drivers on top of that, because the reality is you will have to build likely like drivers on top of that. But that is kind of like our equivalent to, if you're familiar with the AWS Aurora data API, like this is our version of of that like data API, which is separate from like the PlanetScale API itself, which is more about like the management and operation of PlanetScale databases, branching, deploy requests, all those types of things too.
Gotcha. Very cool. I definitely want to chat more about that, maybe on the panel with Yan on too, so that we can sort of put our brains together and talk about that a bit. But that's very interesting to me. I feel like that would help a lot in the context of like edge computing, having access to an API like that on from PlanetScale.
Totally, yeah.
Cool. Well, I think this comes close to our time here. I think at this point I'll transition over, and then we'll bring Emily, one of my coworkers. She's on our engineering team, and Yan on stage, and we'll have a little chat.
Awesome.
Hey everybody, nice full stage. So we've got two familiar faces here. Yan is back, and Taylor. But Emily, you're new on the stage, so why don't you tell us just a little bit about yourself so that everyone knows who's all up here?
Yeah, sure. Thank you very much for having me. Super interesting to hear both of the discussions so far. So my name is Emily. I'm a software engineer at Prisma. I work on the platform team. So these days I've been working mostly on our new subscription API product called Pulse. That's launching in a couple weeks, and I've been at the company for around 2.5 years. I started as an intern, then a working student, and now I've just graduated, so I'm a full-time employee, which is great so far.
Awesome. Yeah, great. So to kick off conversation here, I've got a couple of topics prepared that we can sort of start off with, and then just sort of go from there. I'll also be keeping an eye on the chat, so if anyone watching has any questions for any of us four, please put them in the comments, and we'll discuss them here. But to start things off, I just want to start with a general question. What are you most excited about in the serverless and or the edge spaces right now? What gets you really excited? Why don't we start with you, Emily, since we haven't heard from you as much yet?
Yeah, for sure. So in general, there's two main properties of serverless environments that are very exciting for me. So the first one is the pay for what you use aspect, and the second one is the automatic scaling and the ability to scale to zero. These both make a lot of sense, right? You have better resource utilization, it's more cost effective. But I think it's really interesting because it opens the door for companies to be able to offer very generous free plans by no longer having to support these long-running services that may be idle for quite a bit of time and that aren't being used by paying users, for example. So that's something that I'm really excited about.
Awesome. Yeah, very cool. And then I guess we can move on to Taylor. What do you think about this?
Yeah, I mean, in the serverless space, I'm excited that there's alternatives to using AWS popping up. I mean, the reality is like the underlying fundamental infrastructure is still on AWS. So you're still in a way probably paying AWS. So they're happy. But there's many of these like more specialized companies popping up that build on top of AWS infrastructure. And I think AWS is great at that core infrastructure, that fundamental infrastructure that the internet is built upon. But I'm really excited that then companies can specialize and have developer experiences that are really like focused and really excel at like one thing. The tricky part is like figuring out how all these things combine together. And I think that's going to be like the interesting challenge over like the next like decade, basically, is like, how do we piece all these things together when they're not all made by one company?
Yeah, for sure. That's something that's been interesting to me as well, especially with the Vercel ship event recently. A lot of the stuff they build is on top of AWS, and we saw a lot of very positive feedback to that and a lot of very negative feedback to that. I tend to be more on the positive side. I love that they're building on AWS and that partnership is being made. not to derail the conversation from the first question, but I'm curious what your guys' thoughts are on this topic, like building on top of existing platforms. Do you think it's a good thing that we're, choosing one as a standard for the most part, AWS?
I mean, I can give a, yeah, I mean, I think it's healthy to have options. It can, I mean, if like a really viable option, maybe push AWS in certain ways. I hear, like I said, like AWS is still happy because they still make money off of whatever company building on top of them. So it's not, like really hurting their bottom line that much. And the reality is their bread and butter is a lot of those big infrastructure pieces. And if more people are using something built on top of Lambdas, like that's great. Like that will just, push the growth of, serverless on AWS even further. So, I mean, I don't know if that really answered the question, but I think it's healthy.
Yeah, great. I'm curious to hear what you have to say about that too, Yan.
Yeah, I think they probably address actually quite different markets. The AWS, as we probably know, they're not particularly great at DX. Developer experience wise, I think a lot of tooling they offer kind of bare minimum. And I also think people like myself, I'm primarily back-end focused, and I'm probably the kind of people that would be using AWS directly, but also don't think more the front-end focused teams, a lot of some of the full stack teams I work with, they probably wouldn't want to have to learn the whole of AWS so that they can use these Lambda functions effectively, and having something like Vercel, like Netlify, who provides a much better developer experience building on top of the core infrastructure related the competence that AWS offers. I think that's a great way to build businesses that's a cater for different audience. Certainly AWS is really big. It's quite complicated, but then again, there's a lot of good parts you can sort of pick apart and just put together and really nice developer experience by putting some layer on top of that. And I think that's what the Vercel and Netlify and quite a few other companies have done. And I think that's a great thing to better cater for audiences that AWS is probably not doing enough to sort of cater for themselves. And I think that's fine. I think that's great to have that ecosystem of vendors that's supporting the bigger community. I also have to say, we probably should know. I think AWS gets all the limelight in terms of when people are talking about the cloud, but I think I'm not sure about Google, but Microsoft is actually doing a really good job in the enterprise. A lot of companies are using Microsoft because it's a whole package deal. You get the Teams, you get the Office 360, and oh, by the way, you can use our cloud offering for as part of the same package. So they're actually really good with getting into enterprises and offering the whole package. But I guess probably that's why we don't hear about them as often, because a lot of the sort of big tech companies are probably are the ones that's out there making noise about cloud and all that, whereas some boring enterprise that's been there 100 years old company or 100% Microsoft. But yeah, I think Microsoft is also doing a really good job. I haven't done too much with their functions offering in the past, but they work very different to Lambda from what I've seen. You can actually get access to the container underneath, which I'm not sure how I feel about that. But yeah, it's yeah. I guess to answer your question, yeah, I think it's a really healthy thing to have an ecosystem of different vendors that are building on top of AWS and offering a better developer experience for different communities.
Yeah, I think a lot of like the complaints of what we're talking about that I've seen on Twitter and blog posts and things like that is that people say like, why would I pay extra using Vercel when I could sort of build the infrastructure myself on AWS? And I mean, I think my thoughts and answers to these things are, you absolutely could, and feel free to go do that. It will be cheaper, but you're going to be spending time doing that, and it may not be done the best way depending on how well you know the underlying platform. I think when we see companies like this building on top of serverless platforms or just platforms like AWS, that's sort of the trade-off there. Sure, you might be paying a little bit more money, but you get that sort of package deal where things are going to run in the best way that can be set up for your application.
Yeah, I think we had the same conversation years ago about the languages. Why am I writing this thing in the JavaScript or whatever high-level language when I can write the same thing in the C++ to be faster?
Yeah.
Well, sure, but you're going to be spending 10 times as much time to do the same thing, get the same thing done. Your time is not free.
Yeah.
Your time is very more expensive than whatever you're paying over sale.
Exactly. Yeah. Like the whole concept of developer productivity, I think we're still in the really early stages of like how we measure and talk about those things. It's like we know it will save time, but it's like hard for us to actually like put numbers sometimes to some of these things. And it's a lot easier to put numbers to, oh, well, this costs us X amount, or, like things like that. And so I think soon we're going to have to, more teams are going to have to learn how to deal with those like trade-offs and like communicate about them.
Yeah. Yeah, exactly. And also to sort of conceptualize and just understand that sometimes that trade-off of developer experience for a little bit more money is worth it when you think about the engineering hours that would go into, the alternative.
The one of the founders of Honeycomb calls it like vendor engineering. A lot of what we'll be doing in the future is vendor engineering, and sometimes that can be deciding between two different APIs and different API providers, or do we build this or do we use something for this, and like learning how to do those trade-offs. And it gets into engineers having to talk about money, which is sometimes not a topic they like want to talk about.
It's scary.
But the reality is it's just like, being able to pick the right providers and services to use. It's a tricky thing. And it can, if you don't like do it up front, it can sometimes bite you later when you're having some major incident because the provider you picked maybe isn't super reliable or something like that.
And I think a lot of people, especially engineers, they get kind of wary when they hear about like vendor engineering, because we like to have control over things. We like to be able to configure things and get into the nitty gritty. Black box solutions in the past have been something that you avoid. But I don't know, I may have an unpopular opinion about this, but I think to a degree, we're getting to a point in development where a lot of these systems are working really great. Everything's fast. It's just how fast. Everything's, people are setting things up correctly. And it gets to a point where as we've been talking about, you have to consider the trade-offs. Do you really want to rebuild something? There's the meme going on around right now about rolling your own auth. And it's like, it goes along those lines where it's like, do you want to be building this stuff on your own or use something that a vendor's already spent years and years building really, really well?
Yeah, I think I was talking to Joe Emerson, who's the CTO at this insurance company that built fully on serverless. And one of the things that he said was a lot of companies that make the mistake of spending 80% of the time, 20% of the time researching and 80% of the time doing. Whereas if they do the other way around, sometimes they'll probably end up being a lot better because you can spend 80% of the time researching and figuring out there's a vendor that does this already. Then you can spend 20% of the time implementing and getting the same thing done. And what's the thing about the offering? There's something that you also have to say about that as well, just in terms of how expensive some of these solutions are when you're talking about when you've got. I've had quite a few customers who has got literally million daily active users, but none of them are returning users. They're all temporary users, but every single one of them needs to have goes through the auth system. So it becomes super expensive because a lot of these systems are just designed for enterprise and B2C. It's not really their sort of default use case. So the pricing model is geared towards B2B. So when you're talking about the B2C situations where a million customers that logs in once, you can charge the same way as if it's a million people in the same company that comes in every single day. So I think some of the pricing models are just not designed for a lot of use cases that people actually have. So I do understand why the cases where you do want to roll your own auth because it's just too expensive to pay for a proper solution.
Yeah, and I think that's a mindset that a lot of people in the community sort of forget about. Is a lot of people that you see on like Twitter and stuff talking about these things are either hobbyists or they're working on smaller startups. And sometimes we forget to think about like, okay, what if you're a huge business? Then do you want to be paying for this kind of stuff? I think what you just said sort of, hits that right on the head.
Yeah, I think that's a really difficult thing because everyone just sees their own context. Very
Mm.
few people actually experience both sides of the aisle, and they can actually relate to a question of thinking about both sides of the fence. I've seen a lot of people say the same thing where, oh, this will never work, and then you find out they work in like a 10,000 people company. And of course, whatever works for someone who's like a startup, but it's not gonna just work out of the box for them. But it works for a lot of people out there.
Yeah, absolutely. Cool. So I think, well, let me check for questions. Doesn't look like we have any questions from the chat right now. So I am going to propose a new topic here. I want to talk a little bit about the current state of developer experience working with serverless, and specifically when working in like a full stack application with serverless, including a database. So I guess the question here is going to be like, do you think the developer experience is in a good place right now in the serverless ecosystem, or do you think there's room for improvement? And if so, what do you think can be improved? And let's go ahead and start with you, Emily.
Yeah, sure. So I haven't actually tried out a serverless database in one of my personal projects, aside from like setting it up and playing around with it a little bit. So I can't comment too much on that, but at Prisma, we've built our new subscription API pretty much entirely on Cloudflare edge workers, and they're durable objects. And the development experience there has been pretty smooth, I would have to say. Deployments are super fast, like assigning custom domains, generating certificates, all that. It's super seamless. I guess like the one kind of trade-off that comes to mind is like the configuration aspect of it and the learning curve there. So with Cloudflare, you have a wrangler.toml file and you can configure your environments and your bindings, variables and things like that. And that's like not necessarily shared on other platforms. So yeah, there's sometimes a feeling of focusing quite a bit on a framework rather than like learning more fundamental things that are going to stay relevant for a longer period of time. But that's not to say that it isn't worth adopting a serverless platform like Cloudflare. Like I think it is still worth it for a lot of these projects. It's just something to keep in mind.
Yeah. Did you have much experience working with like Cloudflare before you started on this project, or was this pretty new for you?
This is the first time I'm using Cloudflare. But yeah, their docs are also super clear. New features are being released all the time, which is great, but also kind of hard to keep up with. And also figuring out compatibility between like versions. Like just today, we upgraded to Wrangler 3.0, and like my Mac OS wasn't compatible with.
Oh, really?
I think I'm running like, my version was like 10 and it needed 13. So luckily there was an error and I was able to upgrade my computer today, but it's like, it's hard to keep up because they're moving very fast.
Yeah. I think that's sort of where I was going with the question is, when you were learning all this stuff, was the learning curve pretty high to get into it? Especially, I mean, with Pulse, this is a full, like pretty big complex product that we've built. Was it pretty difficult to jump in and start working on that? Or do you think the resources available were pretty clear?
I would say the resources were pretty clear. Like it's very quick to start. And then when you do get a bug, you end up going down this kind of rabbit hole. And that occupies quite a bit of time because you just didn't realize that the platform doesn't support some very specific thing you're trying to do. But getting up and running is super quick.
Gotcha. And Taylor and Yan, do you have any experience with sort of any of this stuff? Any thoughts on, jumping into working with this?
I think of it a little bit not necessarily as focused on the database stuff, but I was introduced, I guess this was 2 years ago, to Next.js and this like concept of being able to, create like API routes, like part of the Next.js app. And it had this like really good getting started experience of, I love writing APIs. It was like a really quick way for me to write an API. I think where I kind of, and it also introduced like this more back end to like more front end engineers. So it kind of shifted the window that front end engineering is like capable of, which I think is pretty awesome. Where I'm like more concerned about like the bigger developer experience is like at scale. And this idea of like, and I've always grown up in engineering environments where you had like the front end app and then you had the standalone API that the app interacted with. And those were often built on Ruby on Rails, PHP and Laravel, Python and Django or Flask, like Java and Spring, these like frameworks that have been around for a while that enterprises are using. And so I guess my question about the developer experience is like, what is the developer experience at scale? Like, it's got a really great getting started experience in introducing these more like back end concepts to front end engineering. But like, what does that look like over time? And I'm kind of unsure, like, will you see a lot more of these like APIs that are built into whatever JavaScript framework like last, or are they going to come to a point when they're like, okay, time to split out the API into like a standalone application because, we need to build at like GitHub scale or something, stuff like that. I don't know if it's been tested at those levels.
Yeah, and I know along this topic, Yan, I actually listen to your podcast a lot where you interview companies who are working in serverless systems and sort of talk about how they've set things up and what's going on with their development team. So are there any things that you've noticed once you get to that enterprise level that people commonly do to improve the developer experience working with serverless systems?
It's probably not specific to serverless, but a lot of enterprise would have platform teams. I think that's quite an important component to provide some kind of a centralized governance for your entire cloud assets, and also to provide automation for doing things that are probably kind of be quirky and specific to your organization. And when I was at the Zone, we also had a platform team that build a lot of the sort of custom sort of tooling, so for some of the specific CI/CD type of things we do, but also in terms of things like provisioning new accounts, environments, and we had a separate, we had like our own CLI tooling. So I think large enterprises often would benefit from having a platform team that takes care of a lot of the sort of grunt work of working with a large AWS, large and complex AWS environment. Even simple things as like how do you manage your environment where you've got 500 AWS accounts and making sure that all of the stuff, audit stuff is set up properly. And if there's, especially if you work in a regulated environment, how do you make sure that everyone is following security guidelines, and how to detect non-conformities and things like that. So there's a lot of tooling that need to be done, and they needed to be done consistently across a large number of different teams in different areas. So platform team is probably the sort of the approach most companies are taking in terms of how do you tackle these kind of problems.
I think that begs the question, like with these platform teams, creating custom tooling, custom scripts and stuff to do all this, is that something that can be packaged up and sold as a product, or is this really like it depends on your business? Is it like really specific?
A lot of them are kind of specific, but I've also seen some examples of companies that are open sourcing some of the internal tools that they've done. I think Netflix actually kind of did this for a long time. They got lots of tools that they've built and open sourced for people that are running at the really big scale, because they hit scaling problems that nobody else did, or before anybody else did on AWS. So they open source a lot of tools to solve problems that none of the other AWS customers have had. There's also, let's see, what's the other thing I was going to say? There's also at the Zone, we also had like a DX team, so focused specifically on developer experience that kind of work closely with the platform team and they also kind of help manage a lot of the sort of I guess internal libraries, that the utility libraries and very different kind of libraries that many teams would use, but has no clear ownership as for particular service or particular front end application. So that's also part of the things that I think was really helpful for us. And we had a couple hundred engineers, which is not it's big, but it's not big. But even at that scale, having multiple locations as well, having someone being able to someone with the bandwidth to take on a lot of the problems that you find that's going to affect all the different teams is actually really important for any kind of large enterprise, I think.
Yeah, I can imagine that, as your team grows, I mean, a couple hundred or even 100 engineers to me sounds like a lot of people. So, when you're working with that many people, like you said, across different, maybe different sites even, it would become important to, especially when you're using like custom setups, like custom scripts and things that we've been talking about, to sort of set up a standard for the developer experience. That way everyone's on the same page and can jump into other things without having, too much ramp up time. So yeah, that seems like something that is very important for an enterprise team.
Yeah, I think there's also a lot of problems with bandwidth that, there's some shared code that we should be improving, but I don't have time to do it because I've got a deadline, and then you don't have time to do it because you got a deadline.
Yeah.
Someone needs to, at some point, needs to take ownership and just get it done so that, you got 10 different teams all waiting for this, this fix. Want everyone to be finding their own workarounds and hacks, and over time that's going to just build up.
Yeah, absolutely. Yeah, and it seems like this kind of thing would even be important on smaller teams, but maybe less feasible because resources and the amount of time people can spend. But I know on small teams I've worked on, each individual developer is finding their own cool tips and tricks and little processes they set up that the rest of the team would really benefit from having put together in a place as a standard. I mean, I can see how that problem would only amplify as your team grows. Well, very cool. I think we're actually coming up on the end of time, and I'm not seeing any other comments. But before we close off this panel, I just want to see if there's anything that any of you three want to specifically mention before we close out. It could be anything, just something maybe you wanted to talk about or wanted to say.
Yeah, I guess maybe back to the question about the data API stuff for PlanetScale. I think the probably is worth just explaining why I asked that question, just because I do a lot of stuff with AppSync, and also when it comes to building serverless applications, I kind of prefer to use the direct service integration, so that I have to write a Lambda function and stick it in there just so that I can call an API. And having something like AppSync or API Gateway to do it for me, cheaper, and the faster. And so, when the AWS has that Aurora Serverless V1 had a data API, I can just connect my GraphQL API to the data API without having to, put a Lambda function in there just so they can maintain a database connection. It means that I can save myself a lot of the custom code and extra resources I got to pay for and manage, which is why when they released the Aurora Serverless V2 without a data API, everyone was up in arms and goes, "This is."
I remember, yeah. I mean, Corey Quinn had a whole blog post just about. I feel like that problem that they didn't have the data API, and they were like, "Oh, it might be." I can't remember what the official line was, but it might be coming soon, or it wasn't very clear what. But yeah, I mean, I know a lot of people loved that data API for V1. Yeah, and so for us on PlanetScale, Database.js is kind of like our version of the data API. We hope to have potentially in the future other drivers and stuff. We're actually documenting that gRPC API, but the reality was we didn't want to just give out the gRPC API because it wasn't going to be super particularly useful to users. And so that's kind of why we created a driver library on top of it. But yeah, I mean, it's basically kind of very similar, our equivalent to Aurora Serverless Data API. But yeah, I mean, I knew, that was I was really excited about us releasing it because I knew how unhappy people were with Aurora Serverless V2 not having that data API.
So with your data API, does that mean that I can't just hit it with a HTTP endpoint? I still have to have a Lambda function with the Node.js driver?
So you would still have, so you would still have to use, you would still have to use the like JavaScript package to
Right.
do it. I mean, hypothetically, if I mean, it's hard. Like, not a lot of people are using like gRPC APIs on their own. It's, since it's not as easy to use as REST, and like we have to translate. I mean, you can go look at database.js code to actually see what we're doing to like translate it to actual usable query responses, because otherwise it just would not have like a very great experience. Otherwise, we do have a blog post or docs or blog posts or both on using it with Lambda functions. But yeah.
Yeah, I think the goal for the data API for Aurora serverless is so that you don't have to have a Lambda function, because there's just HTTP API that you can hit. So being able to do that, that's how I'm able to, that's how I tend to use for my AppSync APIs, just so that I can avoid having a Lambda function, which comes with cold starts and extra costs and other things as well.
Yeah, I mean, and we were really more focused on like the edge use case, even though we do call it. What to call it was a very difficult thing for us. Like,
naming is hard.
It's called like the serverless driver. I mean, it really is. I mean, you can use it in serverless environments, but it's really geared at edge compute environments, because that is where the constraint of not being able to use the MySQL like protocol really lives, because pretty much I don't know of an edge compute environment that can use the MySQL protocol. It needs HTTP. So that was really what we were trying to solve for with that.
Right, gotcha.
Interesting. Cool. It looks like at this point we're about a minute over, so I think I'll call it here. But just again, I want to thank all of you guys for coming on and having great conversations with us. It was the same as the last one. I learned a lot during these sessions, and I really appreciate it. So yeah, I think with that, I'll go ahead and transition over, and I'll pull you guys off screen. But thank you guys.
Thanks so much for having us.
All right, that was a super fun session. Thank you again to all of the speakers and for everyone watching for just coming along for the ride. This was the second event of this series, and we do plan to have more. We haven't nailed down a date yet for the third one, but it will be coming. So keep an eye on our socials. We also have our prisma.io/serverless website, which is where we'll be posting the agenda once we get that. So keep an eye out for that, and we hope to see you join again for the next one. But for now, I think I'll call that a stream, and I hope to see you next time. So thank you, everybody.